Okay, we are now going to look at the ambiguous case when doing the law of sines. So we'll do a couple examples here. So I wouldn't worry too much about this. I just want to expose you to the idea. There's one problem on the homework that deals with this, and it actually is accompanied by a video. And so that way you get a little bit of experience with it, but I wouldn't lose sleep over this. So the way that I'm going to teach it here, instead of trying to lay out all these possible cases like the book does, I'm just going to treat this like a problem with a triangle, and I'm going to go to solve it. And what we're going to find out is that as we try to solve it, the equation, it will be a trig equation, and it'll have two solutions, or it could have no solutions. And if it does have if it has no solution, then there's really no triangle that's going to solve this. If it has two solutions, either both of them are going to be viable solutions for triangles, or only one of the two will be a viable solution for the triangle. So we will see how this works here. So let's say I have an angle. We'll call it angle A is 30 degrees, and then side A, so the side opposite of this angle, is 9, and then this other side B is 15. So what I'm going to do is I am going to draw a 30-degree angle like this. Okay? And so let me do that. So we'll say that this is 30 degrees. So now, what I'm going to do here, this is 9 here, and so the side opposite of this is 9. So maybe I'll try to bring this down here like this, and we'll say this is 9, and then we'll say that this is 15 here. So we got two sides, and we got this angle here, and so let's call this, since this is 15, let's call this B. And so what I want to do is I want to try to find angle B. I got one angle on the opposite side, and then I want to try to find angle B. And so we'll always start out with what we want to find. And so I'm going to have the signs on top this time, and I'm going to start out with that angle. Sine of B over 15. Okay, and that's going to equal sine of 30 over 9. Okay. So this would be sine of B is equal to sine of 30 over 9 times 15. Okay, so let's see what I get here when I do this. So sine of 30 divided by 9 times 15. And it looks like I get like 0.833, we'll say, approximately 0.833. So notice this is a trig equation, a basic equation, okay, that can be solved, okay. We want to find the angle in degrees. That's going to give me, the sine of that angle will give me 0.833. So in other words, it would be like this equation. So I'm going to do sine inverse of 0.833. Okay, so sine inverse of 0.833, and this is going to give me 56.4. Okay, and so that means like this would be like 56.4 degrees. And let's just keep things to a whole number here. So I'll say 56 degrees. Okay, so now I got two angles and at least one side, so now I should be able to find the other side here. So I'm going to find this angle, so we'll do 180 minus 56 minus 30, and I get like this angle is 94 degrees. So you can see that not everything here is necessarily the right dimensions. Okay, so this diagram, you don't want to rely on it too much. It's just kind of holding things together in relationship to one another, even though like if this 56 and that 94 look like the 94 is less than the 56. So something clearly isn't quite right there, but that's okay. We're gonna do that anyway, and so now I can find this. We'll call that x there. And so what I can do right under here, I'm going to find that missing side, x. So x is to the sine of 94 degrees, as we'll say 9 is to the sine of 30 degrees. Okay, so basically x is 9 sine of 30 times sine of 94. Okay, 9 sine of 30 9 divided by sine of 30 times sine of 94, and I get that this side over here is approximately 17.95. Okay, so again, this side doesn't look much longer than this, but this is telling me that it is longer than this. Okay, so this isn't necessarily the right triangle. Okay, but that would be the solution then for that triangle. Okay, except when I solve this equation over here, remember that for the sine here, there's actually two possible angles between 0 and 180 that'll give me 0.833. Okay, so let me draw the unit circle here. And so like right here, we'll say that's 0.833. So we have an angle over here, and that's like the angle that I got. That's the 56 degrees. Okay, but there's going to be another angle over here, and that's going to be 180 minus 56. And so this is like 124 degrees. Okay, so this is another solution to this equation. So it's another possible solution to our triangle. But to make sure that it is a solution, we have a 30-degree angle. And if this is one of the angles, 124-degree angle, these have to add up to be less than 180. And they do. This is 154 degrees. And so we see that 180 minus 154, looks like that is 26 degrees. So our triangle would have 30 degrees, 124, and 26. So this would be one triangle. This would be another triangle. So I'm going to try to draw this. 30, 124, 26 degrees. So I'm going to try to draw this. And as it turns out that it's going to be more like this angle, because this is my B here. Okay, so you have that 30 degree here, right? 30 degree, and then the 124 is kind of like this. I don't know how it would be, but this is like 124 degrees, something like that. And this would be 15. Okay, and then this one over here would be the 26 degrees. So it would look like this. And so now I can solve this triangle. So this is 9, this is 15, and now I can find this missing side. We'll call that x over here. So we have that triangle, we have this one. So I want to find the x, so I have x is to sine of 26 degrees, as 9 is to sine of 30 degrees. Like that. So x is equal to 9 sine of 30 degrees times sine of 26 degrees. Oops. And that would give me this side over here. So 9 divided by sine of 30 degrees times sine of 26 degrees. And I get like 7.89. So we'll say 7.9 if I round to the 10th place. So this is 9, 7.9, and that would be like 15. Okay? And so this would be like the other triangle. Okay? And so there's actually, because there's two solutions to the sine equation, there's two possible angles that B could be, and since they both make up a triangle, that these make up a triangle and those make up a triangle, then we're good. Okay, now if it turned out that if I added the given angle plus the second solution on the other side, and this ended up being more than 180 degrees, then you couldn't get another triangle out of that, right? These two have to add up to be something less than 180 degrees so that you can get a third angle. And we'll do an example like that here in a second. Okay? But that's the idea of the ambiguous case, because the sine equation has two solutions, and that both solutions can end up with a triangle, then it turns out that there's two different triangles that can be made out of the information that you're given. So it's ambiguous. You don't know which of the two triangles it is. So let's actually try a couple more here. We'll try to do this. So we have like sine, or we have 65 degrees. So I'm going to try to make a 65 degree angle like this, maybe like that, 65 degrees. And the side opposite that is going to be 5. So this is like 5. And then we'll say this is side B, that's 7, and we'll call this angle B. Okay? And so what we're going to do is, so that's how I do it. I just draw the angle like that. This opposite side is the A, and then I always have B up above. That's just how I do it. There's other ways to do it, but so now what I have here, I'm going to try to find the B, so I get sine of B is to its side as the sine of 65 degrees is to its side. And I'm going to go to solve this. Sine of B is equal to sine of 65 degrees over 5 times 7. And let's see what I get here. Sine of 65 degrees divided by 5 times 7. And you see what I get here is 1.269 if I round to 3 decimal places. So I'm just trying this just like before, setting things up, and what I find here is I get that the sine of B is equal to something bigger than 1. That is not possible, right? This equation here has no solution. There is no angle B such that you can have this set up. And so this information here does not result in a triangle. And that's how you know. You just go, try to set it up, and then you'll know that it doesn't result in a triangle, okay? Because you won't be able to solve the equation. Okay, well, let's look at one more case here. My angle is 45 degrees. So something like this, and my A is 8. So we'll say that this is 8. This is 45 degrees. And my B here, this is 3. So again, something with my dimensions is not right, because this one actually looks longer than that, doesn't it? But that's okay. I'm not sure exactly what it is. Probably this thing should go down. This thing should probably go down like this to make that 3. Okay, so I probably didn't do my triangle very well. Maybe what I can do is I can try to do that a little better. So maybe something like this. So this is 45 degrees, right? This is my B. This is 8. And this is 3. Now, that makes more sense. That's probably what the triangle looks like. And so what we're going to do is we're going to try to find sine of B. We're going to try to find B. So sine of B is to 3, as the sine of 45 degrees is to 8. And we're going to try to solve this. So sine of B is equal to sine of 45 over 8 times 3. And let's see what we get. And I get like 0.265. And so indeed this does have a solution. And so my B would be the sine inverse of 0.265. And so let's see what I get there. And I get like 15 we'll just say 15 degrees. I'm going to keep it whole numbers. So I get 15 degrees. So what that's saying is that this B here is 15 degrees, right? Now remember, there's two possible solutions. So let's see what happens here. One solution, so this is like 2.6, right? 2.65. Oh, sorry. 0.265. And this is one solution, 15 degrees, over here. The other solution would be on the other side, and that would be 180 minus 15 degrees. So this would be like 165 degrees over there. These would be the two solutions. But notice that 165 degrees plus this 45 degrees is actually equal to 210 degrees, which is not possible here as far as making a triangle, right? You can't have these two angles plus another equal 180 degrees. So that means this one does not result in a triangle. There's only one solution, and it is 15 degrees here. So now I can use this to solve the rest of the triangle. So I'm going to do 180 minus 15 minus 45, and I get 120 degrees. So this angle is 120 degrees, and we'll call that x. So I get x is to the sine of 120 degrees as 3 is to the sine of 15 degrees, we'll say. Or I could have used the other 8 is to the 45 degrees. It doesn't matter. So this would be x is equal to 3 sine of 15 degrees times sine of 120 degrees. So 3 divided by sine of 15 times sine of 120. And I get, like, this side is approximately 10.0. So that would be this side, 10.0. 8, 10, and 3. Okay, and those would be the angles. And that would be the only solution because our other angle here doesn't result in a triangle. Okay, so those are the possible cases. Now what I would encourage you to do is, if you have a case like this, don't worry about the ambiguous case, just go to solve it. You would get at least one of the triangles. And in fact, I did this on purpose. So there was that nice video that I put up that introduced the law of sines. This was actually one of the triangles she did right at the end. So she did this triangle and got the solution, this first one with the 56 degree, and you didn't even know. She just did the problem, and you didn't even realize that there was a second triangle here that also worked as well. So you can always just do it. You'll get the one solution, and you would just miss the other triangle. But depending on the situation you're in, it's good to know that this ambiguous case exists, and just to know that it's out there. Okay, and that's what's going on with that ambiguous case.